voice. So by chance, if you are not able to hear or see the screen, please do let me know. It is advised that you unmute yourself and let me know, because I'll be presenting my screen. So if you are writing in the chat, I won't be able to know just for today. Okay. Very good morning to each and every student of mine present here in the session. And your fifth semester has started. Half of the engineering is over. So in this fifth semester, we are starting with your new subject today. I'll be presenting you my screen first. I'll let you go through the syllabus. What is the name of the subject? What is the credit of the subject? A little bit of introduction about your syllabus of this particular subject. What is the name and the subject code, which you guys should remember. How many units we are going to cover in the entire semester? What is the book that you guys can refer to cope up with the study of this particular subject? How many practicals are there? A little brief, though I guess B batch students have already briefed about them in detail. A batch students, whenever the lab is coming up, I'll tell you in detail, but I'll let you go through how many practicals we have, and then we'll start with your unit number 1 today itself. Okay, so just acknowledge when you can see my screen. It will take a little bit of time, so when I ask, you tell me yes or no. Okay. Okay, are you guys able to see my screen?
Yes, ma'am.
Yes, ma'am.
Each and every one?
Yes, ma'am.
Yes, ma'am.
Okay, fine. See, for your fifth semester, the subject name is Design and Analysis of Algorithm. In short, DAA. DAA. Okay. The subject code is 01CE0503. 05 is your semester, 03 is the actual subject number. So 01CE0503. It is a 5-credit subject. Okay, and the basic objective of this subject is to let you go through the knowledge of how an algorithm is designed and how it is analyzed. So if any one of you are interested in research work, this can be one of the important subject for your understanding. Okay. There are some course outcomes which are targeted, like what you should understand. You should understand how the algorithms are performed in various ways. You know, there are quite algorithms now because of your data structures. Can anyone name any algorithms that you know in data structures or in OS you have read or remember? Any one of you? Any algorithm that you remember? The name, just the name. Nobody remembers any algorithm? Search algorithm or any kind of sorting algorithm, anything that you remember? The names? Push, pop, FCFS, okay. Then I'm talking about algorithms. I'm not talking about methods. They are right. You guys are right, but those are methods. Banker's algorithm, right? Round robin, okay. Then binary search, exactly, Kushant. FCFS Sabij again, it is a method, first come first serve. Okay, you'll learn about it. The insertion, yeah, bubble sort, insertion sort, correct. Merge sort, binary and linear searching, right? knapsack problem. Those are what your kind of your algorithms. So how you are going to analyze the performance, that is what this subject is all about. Okay, how we are going to evaluate or analyze that this particular algorithm gives me the highest required performance. Okay, that is what this subject is going to help you to decide. Now, what is the prerequisite of this course? The prerequisite is you should be knowing the data structure concept. That means your arrays, your linked list, okay, tree functions. You should be having a proficiency in any one programming language. It can be C, it can be C++, okay. A little bit of mathematical function knowledge, logarithms and graphs. All right, that much will be enough for you to understand this particular subject. And now this is prerequisite. Okay, now prerequisite doesn't mean that if any of these concept is coming in between, then I'm supposed to go in depth with those concepts. As it is a prerequisite, you should be able to do it on yourself only. Okay, whatever will be the concept new with the subject, that I'll go deep. But if you ask me that, madam, in this data structure, I'm not able to understand what is the struct, then it is not going to be, you should not expect me to go in deep there. Fine. Yes, I'll give you the reference that you go and refer this particular, material, or you go and refer this particular thing. You'll understand that I can help, but I cannot go and go deep with the data structure part or any mathematical function or logarithmic part in deep. That is you yourself have to do because it is listed here in the prerequisite of the course. Okay. Fine. Coming to the teaching scheme now. The teaching scheme, the theory marks, as you are aware, mid-sem you have 30 marks. Internal assessment you have 20 marks. Okay, Viva you have 25. Term work you have 25. Now, term work is nothing but your lab submissions. Okay, in your lab submissions, you are going to have like 25 marks for those lab submissions. Internal, you'll be getting the assignments. Okay, so 20 marks for that assignments. Mid-sem, as you all know, 30 marks. Your external examination, it is listed here 50, so it will be scaled up again. And you have Viva of 25 marks. So that is your teaching scheme for this particular subject. Now this subject in total contains 9 units. Okay, so in this entire semester, we are going to go through the 9 units of this particular subject. The first one is the basic introduction one, like what is your design and analysis of the algorithm, what is algorithm, mathematics of your algorithmic sets. The set theory, if you can remember, I think it will be in your semester 1. Set theory, subset, equal set. Do you guys recall anything like that? Union. So that is what we are going to go through. Power of the set, union of the set, subsets, okay, equal to, not equal to, those things we are going to see in this particular unit number 1. What are the functions, relations, vectors and matrices, okay, that is what we are going to see. From unit number 2, we are going to start the analysis part of your algorithm, okay. How you can say that the algorithm is an efficient one. Okay, what is your average case? What is your best case? What is your worst case? Some of you were asking me in data structure when we were discussing in the data structure, especially TD2 students, that somewhere we are seeing that there are some omega notations. They are saying it is big omega. Somewhere it is saying it is the worst case, it is the best case. At that time, I told you that in your higher semester, you are going to see it all in the detail. So here it comes, everything. So average case, best case, worst case, how you can analyze, how you can decide that it is an average case analysis or it is a best case analysis. That is what going to getting discussed. You have amortized analysis and asymptotic notations. Asymptotic notations is nothing but that big O, big theta, big omega. Okay, so your sorting techniques will be analyzed here. Sorting of the algorithms and their analysis. Like if we are talking about bubble sort, okay, then bubble sort, what is the best case? What is the average case? What is the worst case? If we are talking about insertion sort or bucket sort or counting sort, Okay, so everything we are going to discuss this in the analysis part, so that you are getting used to how you are going to analyze an algorithm. Okay, then comes the divide and conquer part. Okay, so metrics, problem solving like divide and conquer, binary search, max or min problem, everything we are going to analyze or divide and conquer. Then we are going to come to the dynamic programming in unit number 4. How we are going to solve using dynamic programming, kellogg's, mallocs, or your coefficient, knapsack, matrix chain. Fine. So that we are going to see. Then we are going for the greedy approach problem. How greedy approach and dynamic programming are going to differ, that you are going to see by general characteristics of greedy algorithms. What are the elements to strategy a greedy algorithm? How you can solve the different problems using greedy algorithms or greedy approach. Okay, that we are going to see. Then comes your graph algorithms and backtracking and branch and bound. So all these, a little bit of mathematics here. So if you are not able to recall those mathematics, then I would advise that you open up your books of mathematics, at least logs and set theory. Okay, so it will be helpful for you. The last two units are string matching and NP completeness. What is class P? What is NP? Polynomial reduction. Okay, NP hard problems. Everything we are going to discuss in your theory session, and this is all consisting of your 9 units so far. Now in the practical session, okay, wait, your reference books. Okay, it is Corman, Thomas H. Corman. In short, we call it Corman. So Corman is, you can say, one of your standard book to refer, Introduction to Algorithms. I'll upload that soft copy. I do have a soft copy of Corman, so I'll upload it in the e-content. You guys can find it today itself. Okay, then comes Fundamental of Algorithms by Gil Broussard. Okay, so if you are comfortable, you can go for this one also. Last number 3, 4, and 5 are extra books, or say extra references. So if you are comfortable with any of the 5, I don't have any issues. You can take a screenshot of this particular screen, so that you can keep a reference, and students especially who are here in the hostel, okay, you can come to the library and just have a look to these books. For you, I'm keeping this window open. You can take a reference. All of you can take a reference. Okay, take a screenshot, and for, I would suggest that Corman is good book. So the number 1, that's why, Introduction to Algorithms, and I have that book also in soft copy. I'll upload it. You can find it today in the evening. Fine, so these are your references. I hope everybody must have taken the screenshot. Hostel students, you can take an advantage of the library here and have a look at the book physically. Those students attending this online and no resource to have the book physically, you can just go online to search these books. Corman, you won't need to search, as I'm going to upload it myself. Okay.
Hello, ma'am.
Yes.
Ma'am, will we be using any programming languages to implement the algorithms or just theory?
No, you'll be using the programming language. Language you can choose either C or C++. That is what the next point is. As you can see, the suggested list of experiments. In total in the syllabus, you have total 18 experiments. Oh. You have total 18 experiments. Okay, but out of those 18, we are going to do first 12. Okay, so whatever you can see on your screens, the first 12 algorithms we are going to see. Now, for implementation of these 12 practicals, you can select C language or C++. Though I am going to keep
Ma'am,
C. Yes, Yaro.
this file we can find it in e-content.
Yeah, because right now I have not uploaded. I'll upload this syllabus as well as your Corman book today. So in the evening, you can check it out.
Okay, ma'am.
Fine. Here, see, I'm giving a little bit of liberty to all of you. You can choose C or C++ to implement the program. But if you are choosing any one language, C or C++, then you have to see that you implement all the 12 programs in one language only. Okay, I don't want student doing first 4 you did in C, then 5, 6, 7 you are doing in C++, again 8, 9, 10 you are doing in C. I don't want that. If we are doing this, then I'm really sorry, I won't be evaluating your programs. One another thing, I'll be explaining you all these programs in C language, because if I am giving you the option, even I'll be having the option to explain. So I'll be explaining you these all practicals in C language. Okay, but you have a choice, whichever you are comfortable, but keep only one language throughout your 12 experiments. Fine, I don't want combination. Secondly, I am going to keep a specific format. If I don't get that format, this is for all the students. I'm not giving TD1 students or TD2 students. This is for each and every student of mine who are under me in DAA. I am going to provide you a specific format only, and I want in that format submissions. I will see first of all the format. Whenever I'm going to keep it the same only, which we were used to do in OS. Okay, I'm going to create a Google Classroom for you. Okay, for B batch I have already created. For A batch I'm going to create when you come for your lab. I am going to create a Google Classroom, and you can find your format today in the evening again. And I want in that format only. Any changes in that format, and I'm not going to evaluate your program any further. The first thing that I'm going to see is my format. Okay, if any innovation is done, or if the student is submitting in his or her customized format, then I'm sorry, I'm not even going to see what you have submitted me. Straight away I'll just put your assignment or your submission aside, because last time it created a little bit of mess for me when I was evaluating your particular assignments. Some of you did some smart work, so I had to be smart with you. I'm not taking up names, but what you guys did was you did submit your friend's submission by just cropping up the name and the enrollment number written on the very top of the page. I told you to give me scanned copies, and what some of you have done is this particular smartness. Now, if you think you are smart, then I'm your professor. I know what you things are going to do. Okay, so accordingly, I had evaluated. But this time, if you do this smartness, I'll take up names in front of all the students of mine. So if you don't want this particular scenario, please see to it that you are sincere enough in your work. Secondly, you are following the format strictly which I am giving you. No adjustment in the formats I'm going to allow. If any student comes up, then madam, I'm getting this kind of issues with the format. Can I change your format? No. You adjust, okay, with your write-up or your content, but my format should not be changed. Am I clear with this to everybody, whether it is regarding your assignment or whether it is regarding your submission of the practical? Am I clear to each and every one of you?
Yes,
Okay, perfect, fine. Don't worry, it is not going to be very tough kind, but I want to keep everything in a uniform way, so that it is easy for you to submit and it is easy for me to even evaluate. All right.
Okay, ma'am.
Fine. So this is it. Okay, and this is all your syllabus is about. So I'll be starting with your unit number 1 today. I'll present my screen again. Okay, wait. All right, visible?
Yes, ma'am.
Okay, everyone, I hope it is visible. Fine. Okay. Your unit number 1 is basics of algorithms and mathematics. Okay, the outlines of this particular unit is we are going to see what is an algorithm, what is the mathematics behind these algorithmic sets, functions and relations, what are your vectors and what are your metrics, linear inequalities and linear equations. Now, see, the subject is all about analysis. Okay, so analysis means kind of a comparison. Fine. So, in order to compare in engineering language, okay, you do need mathematics. So, that's why the unit number 1 is about the basics of algorithm and mathematics. Some of the terms you will be able to recall, some of them you won't be able to recall. So, it is perfectly okay. Don't worry. Okay, if you're not able to recall, you can refer here and you can go back to your mathematics a little bit later on. Okay, and just refer what is the concept is all about. Fine. Now, before I start, you guys tell me what is an algorithm for you. I want at least 4-5 answers. Okay, so start speaking up, everyone. Whoever wants to speak, you can unmute yourself and tell me what you understand by algorithm. Simple language. Okay, nothing any scientific or engineering language. Simply tell me when I say what is algorithm, what do you understand? Or what picture comes? Okay, Utsav says a set of rules. Okay.
Ma'am, a set of rules, yes.
Okay, Jai too. Kushant is telling solving problems step by step. All right. Anybody else? What idea do you get when I say it is we are going to study algorithm? So what idea do you get? Manipulation of the data structure in efficient way. Okay, good point, Ayush. Anything else? Anyone?
It's like a formal to solve a problem.
Formal what, Yaro?
To solve any problem
Okay,
like this.
formal way to solve any problem. Okay. Anything else? Correct. Anybody?
It's a way to solve a problem step by step.
Correct. Absolutely right. Chianidhi, you are also right. All of you, if I merge all these points, becomes the answer to what is an algorithm. It is defined as the collection of unambiguous instruction. See, this word is important. Your algorithm should not contain ambiguity. What is ambiguity? Anyone can tell me? What do you understand by ambiguity first? Anyone knows what is ambiguity? It should be simple. Correct. Means it should not be running in a continuous loop. Okay. Unambiguous instruction occurring in some specific sequence. There should be some end. Because see, most of your algorithms, most of your higher programs, they are going to contain loops, right? It can be for loop, it can be your while loop, do while loop. But there shouldn't be a case that the loop is, endlessly going, running. Ambiguity should not be there, right? So unambiguous instructions occurring in a specific sequence. Of course, it should be in a specific sequence, right? That you first read integer a, then you read integer b, and then you do the summation or say the operation on both the integers. So it is a specific sequence. You are not going and giving the command that okay, do a plus b, then you go and declare a, and then you go and declare b, right? You are following a specific sequence there, and such algorithm should produce some output for given set of input in a finite amount of time. It should not take an entire century or entire time to give you an output. There should be a finite amount of time. So when I summarize all the points that you guys have suggested of what you understand of an algorithm, it becomes this particular definition. An algorithm is defined as collection of unambiguous instruction occurring in specific sequence, and such algorithm should produce some output for given set of input in a finite amount of time. Okay, so if you put it point wise, an algorithm is a sequence of computational steps that transforms an input to an output, because you are giving an input, right? So you need an output, and for that output you are not supposed to be waiting for an entire time, because today even if we wait for 2 minutes, the common phrase that come out of our mouths is what? It is taking too long. So that means we are not even patient enough to wait for 2 minutes. Then of course our program should not be running for years and years to come, right? So that's why finite amount of time. Again, your algorithm is what? A tool for solving a well specified computational problem. Because we have a problem, we are defining a set of sequence to solve that problem. Okay, so our algorithm is what? A tool for solving well specified computational problem. Correct? Now, going more into it, if you want to write it pointwise, then again, this is the slide for you. Okay, that if you don't want to write in that paragraph sequence, it is difficult for you to understand, then you can go for like this only, that an algorithm is a set of rules. Point number one, for carrying out calculation either by hand or through machine. I'll explain you how you can go for hand, but those programs are very simpler ones, very small ones. Okay, or you can carry out this algorithm analysis of this algorithm on machine. Second, what is your algorithm? A finite step-by-step procedure to achieve a required result. And that is your point number two. Point three, it is also the sequence of computational steps to transform your input into output. Okay. Or fourth step, what you can say about algorithm is operation performed on the data that have to be organized in the data structure. Okay, you are going to perform, let's say you want to perform, there is a problem that you want summation of two integer points, or say integer kind of data. So you are going to organize first those data, like you are going to first go and write what? Integer a, then you are going to write integer b, or you can write integer a comma b. Then you are going to declare an integer sum. You might initialize it to 0, and then you are going to go for the summation part, sum equal to a plus b, and then printf and print sum, percentage d sum, right? So what is this? The sum steps, the steps you are going to follow to perform the operation of addition. So that becomes your algorithm. Everyone clear with the definition of algorithm?
Yes, ma'am.
Yes, ma'am.
It was an easy language, I suppose. So, but still, if anyone is having any kind of questions here, you can ask me. All right. So how can I characterize? What is the characteristics or say the properties of algorithm? Okay. As you can see on your screen, the very first thing is non-ambiguity. I have already discussed. Ibrahim, you can use your plain English, provided you are using the specific words that go along with the algorithm definition. It is not necessary that you copy paste exact words and sentences which is there in your textbooks. You can explain in your own words, provided you are using some technical jargons in between. Just excuse me for a minute. Just give me a minute, okay? The very first property of your algorithm is non-ambiguity. Okay, so what does it mean? Each step must be precisely defined. And that means there should not be repetition, or say, suppose you are using any loop, then the loop is running for the entire amount of time. Okay, that should not happen. Actions to be carried out must be precise and clear for the each case. Okay, then comes the property of range of input. An algorithm can be or has 0 or more inputs taken from a specified set of objects. Now these objects can be your predefined program also. Like sometimes I tell you, no, that don't hard code your input. What we do is integer a equal to 10, integer b equal to 10, sum equal to 0, sum equal to a plus b, and print sum. So what we are doing, we are hard coding our input, because we are directly defining, as a programmers, we are directly defining that a is of value 10, b is of value 10. And you must have been listening or say heard from me that you do dynamic programming. Keep your program dynamic. So what do I mean? That you take input from the user. So that's why the specified set of objects. What I mean is either it is hard coded or either we are keeping it dynamic so that we can take it from the user. Okay, and the algorithm can have range of inputs that can be 0 or more inputs. Multiplicity, it is represented via different methods. That means you can write your algorithm as step 1, you must have seen in data structure or in the OS algorithms too. I am writing step 1. Okay, then integer, declare integer variable. Step 2, give the values to integer a. Step 3, summation of a and b. Or you can write it as just 1. Okay, initialize an variable. 2, give the values. 3, do the summation. So that is what it can be represented via different methods. You can even represent this algorithm in subset form also. Okay, speed is one of the algorithm, because why we are doing the analysis, we want efficiency because we want to speed up the system, because now we are moving forward to an era where speed is everything, whether it is in data, whether it is in algorithms, whether it is in your driving, everything you want speed, you want to decrease your time. So that is also one of the property of algorithm here. Algorithm should be efficient and fast in speed, right? And the last one comes is your finiteness. That means your algorithm should terminate after a given number of steps. It should not be keeping going on till the entire, taking up your so much amount of time. Because if it takes that much amount of time, again, the property of speed is not getting fulfilled, right? So these are the 5 properties of algorithm. Any doubts here? Anyone? Yes, anyone? Any doubts so far?
No, ma'am.
The rest of the
No,
students?
ma'am.
Okay. The next thing that comes up is how you can express the algorithms. And now, as I told you, in the multiplicity, you are not going to write just in one form, that okay, this is the algorithm and this is the only way to write the algorithm. No, you can write it in natural language. Natural language means how we are so far, writing it in our papers or in the theory. Step 1, step 2, step 3. You can use flowcharts. All right, the diagram which you can using in, no, you guys will be doing that in next semester. Okay, but there are flowcharts of showing how the algorithm is going. Okay, so flowcharts. Pseudocode means you are not writing the exact in the C language or say your programming language, but a little bit of that coming, those commands are coming in between. Okay, so that is pseudocode. Or directly you are showing it in your programming language. Okay, so if I want to demonstrate, if I go for pseudocode, okay, then number 1 is what I'm writing: declare integer a. Okay, Then step 2, again I'm writing declare integer b. Okay, so what is this? It is a combination of a natural language and my programming language. So that is what a pseudocode is. Pseudocode means it is not the exact implementation of the program, okay, but somewhat I'm using a little bit of programming language in showing you the steps. Now in the programming language it is easy that you are directly writing whatever you're going to write in a program. Fine. So your algorithms are expressed in these 4 ways. In natural language, you are just writing the sentences. Declare an integer kind of variable A. Declare an integer kind of variable B. Okay. Add both A and B. So that is a natural language. And in the flowcharts, you are using your diagrams. Okay. So that is what expressing the algorithms come up. I hope I'm clear to all and no doubts here.
Yes, ma'am.
All right. Now comes the mathematic portion, that is a set theory. Okay. Now what is a set? First of all, the definition of the set. Now I'm not asking here that do you remember the set theory or are you guys aware with the set theory? Yes, of course you are aware with the set theory, but there might be a case that many of you don't remember exactly what you have studied in your first semester or maybe in your second semester, or like in 12th standard also you are getting this, Indian students especially in the 12th standard science stream you are getting the set theory. So it's okay, fine. So that's why I'm not going to ask you, I am directly showing you what is set. The set is a collection of different things. Okay, yeah, correct, Jai. Collection of various objects you can say, or various things, and those are your distinct objects, okay, represented as one unit. And these objects are in the set are called as elements or the members. So if you can see, a set is represented by capital letter. So if I say set of natural numbers, so it is capital N. Okay, set of integers, so it is capital Z, right? So capital N is what? My set representer. In between the curly braces, I am going to write the members of natural numbers 1, 2, 3, 4, 5, 6. So those becomes my elements or my members. Okay, so every element which I'm writing in between my curly braces, it is separated by a comma. So if object X, okay, object X is a member of set S, then how can I write, if I want to describe that X is the object member of set S, then I'm going to write X belongs to S. This E symbol that you can see in between, exactly it is not E, okay, but it shows something like E. So that is what belongs to. Okay, so you are going to write X belongs to S. That means object X is member of set S. Okay, if the opposite case is there, X is not the member of S, then you are going to strike out that E. So that means X does not belong to S. Okay, now if I want to write set of vowels, so that is represented by capital V. In between the curly braces, you are going to write A, E, I, O, U separated by the comma. So this becomes your set. Everybody clear? Belongs to, does not belongs to, how to write set.
Yes, ma'am.
This was a part of set theory in your mathematics. Okay, so if you want more insight on this, you should go to your set theory chapter in your mathematics.
Okay, ma'am.
Fine. Now see, your set cannot contain the same object more than once. Okay, and it is not necessary that elements are always to be in ordered form also. So for example, if we consider this set S, so what I'm writing, set S is equal to 7, 21 and 57. So see, these are kind of, you can say, in the ascending order, right? 7, 21 and 57. Correct? But you cannot say that always we are supposed to write it in this order only, right? You can write write it as 21,757 also, 57,721 also. But what you can say about these elements, that 7 belongs to this 72157 set. If we are taking number 8, then we are supposed to write 8 does not belong to this set S. Okay, so 7 belongs to S, 8 does not belongs to set S. Why 8 doesn't belong? Because 8 is not included in the object, or say in the set of S. You can also describe the set containing elements according to some rules also. Rules means you can write n and you can write rule about n. That means all the numbers in the set are following some kind of rules. So something like this, see, n, then colon, n equal to m square for some m that belongs to capital N. Now this capital N is nothing but your set of natural numbers. So the value which you are going to take for this m, okay, is from the set of natural numbers. So it can be between 1 to infinite, like 1, 2, this m can be 2, this m can be 3, this m can be 4, okay, and whatever you take here m value, that will be squared up. So suppose I take m value as 2, so 2 square, so 4. So n is equals to, what can I say, n is equals to 4 afterwards. Okay, so this means you are describing a set with some kind of rules. That means if you write this particular rule, okay, for your small n, it means it is a set of perfect squares. Because see, m I am writing as belonging to set n. N, capital N, is natural numbers. So 1 square is 1, 2 square is 4, 3 square is n. So all these are the numbers belonging to the perfect square set. So what you can say about this particular set? It is a set of perfect squares. Okay, are you guys following whatever I am saying here? Are you guys following it or not?
Yes, ma'am.
Yes, ma'am, for sure.
Rest of the students? All right. Okay, I'll keep the session till here, because in the next slides we are going to see what is an empty set, infinite set, subset. Okay, and we are going to continue with that only, proper set, equal sets, what is a power set, set cardinalities. Okay, so that I want to cover in a continuous form, and it is almost your time, so we are going to keep it till here. Okay, like the introduction about the set. Okay, in the next session, that is I guess tomorrow only, we are going to continue with this, the kinds of set, what are the set, what is set cardinalities, okay, what are the operations on sets, what are the functions and relations, and maybe we'll be able to complete this unit because this is very small unit. Okay, so we'll be able to complete within next lecture, or most probably by next to next lecture this unit will be over. All right, so that's it for today. I'm concluding this unit, concluding this particular session here only. Thank you guys for attending this session. You guys know how I take my attendance. So TD2 students, please be patient. TD1 students, write your numbers in the chat quickly, and you are free to leave the session. Thank you all. Okay, TD1 students, now kindly wait. TD2 students, numbers in the chat. And Lena, please wait for me to announce for TD2. Please don't be in this rush. TD1 student, I told you to wait. Do not write in between.
Thank you, ma'am. Have a
Ma'am, by
nice day.
mistake I have just wrote a roll number and by mistake I have sent, ma'am. I was not intent to send it.
Kushal, please be careful next time. This is going to create some issues while I'm putting up the attendance then later on.
Okay, sure, ma'am.
Okay, thank you guys. You too have a nice day. TD1 students, if anyone is remaining, please write your numbers, but don't repeat it if you have already written once. TD1 students, anyone remaining? Okay. Thank you, students. You are free to leave the session.